Assalamualaikum and good day. Now we're going to continue to our next chapter, which is chapter 2, number system and digital codes. Okay, so here we're going to know about the decimal, binary, hexadecimal, octa numbers. We will learn about number conversion, binary arithmetic, and binary codes. Okay, number system. Okay, usually in current life, in normal life, we use the decimal numbers. This number is the base 10 system. So in base 10 system, there are 10 digit symbol, which is start from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have option of this for our base 10 system. You see, there are 10 digits. 0, 1, 2, 3, 4, 5. All of these there are 10 digits. Okay, the value of a digit is determined by its position in the number. For example, to express the quantity 23, okay, here is the 23. The digit has a weight of 10 in this position. For example, for this one, is actually 3 times 10 to the power of 0, okay, the position 0, and this one 10 to the power of 1, because this is position 1. You see, 2, 3. This is at position 10 to the power of 0. This is at position 10 to the power of 1. The position of each digit indicates the magnitude of the quantity and can be assigned by a weight. Okay. Here, the digit 3 has a weight of 1 in this position because we have 10 to the power of 0. So the weight is 1. Here, the digit 2 has a weight of 10 in this position, 10 to the power of 1. Okay, for example, let's say you have 3, 2, 3. So this one is, the weight is 10 to the power of 2. Okay. The weight of whole numbers are positive power of 10 that increases from right to left, beginning from 10 to the power of 0 to 1 here. Okay. Fraction number, the weight are negative powers of 10 that decreases from left to right, beginning with 10 to the power of minus 1 equals to 0.1. Okay. For the fraction numbers, okay, the weight are negative power of 10. You can see from here is negative 1, negative 2, negative 3, going from the decimal points. Okay. The value of decimal number is a sum of the digit after each digit multiplied by its weight. Okay, the value of the decimal number. Example, let's take this number 2745.214. So you can see that is the corresponding weightage, okay, the corresponding weight according to the position. And after the decimal point, it is negative 1, negative 2, negative 3. Okay, so solution. Okay, solution, you get this one, 2000 plus 700 plus 40 plus 5 plus 0.2 plus 0.01 plus 0.04. You can see here, this is how they calculate it. Okay. Okay. Now, binary number is using the base 2 system, which is only 0 or 1. Okay. Example 00, 01, 10, 11, 100, 101, and so on. So means your bits, your digits is only consists of 1 or 0. So the value of bit is determined by its position in the number. The position of 0 and 1 indicate its weight or value within numbers. Okay, for the binary, you can see here 2 to the power of 0, next to it 2 to the power of 1, and increasing, okay, in weight. For the numbers after the decimal point, the weight is decreasing. Okay, you see 2 to the power of negative 1, 2 to the power of negative 2, 2 to the power of negative 3, and so on. The rightmost bit is the least significant bit. Okay, this one is the least significant bit. In binary whole number, it has a weight of 2 to the power of 0. In the binary whole number, here is the least significant bits for the binary whole number. Okay, the weight increase from right to left, from right to left by power of 2. Here you can see that the weight is increased by a power of 2. Okay. Binary numbers, the leftmost bit is the most significant bit, MSB. You can see start from 20 and is increasing 2 to the power of 4 and 2 to the power of 5 and so on. Fraction numbers, the weight are negative power of 2 that decreases from left to right beginning with 2 to the power of negative 1. Here is 0.5. So you can see it's increasing. So this is our binary point. Okay. Positive power of 2 for whole numbers. Okay. This is example of the range. Okay. From the least significant bit to the most significant bit for the whole number, nombor bulat. And for negative power of 2, from 2 to the power of minus 1, from 0.5, you can see it is decreasing according to the weight as well. Okay, binary to decimal conversion. Okay, the decimal value of any binary number can be found by adding the weight of all bits that are 1 and discarding the weight of all bits that are 0. Example, we convert the binary whole number 1101101 to decimal. Okay. Solution is that we determine first the weight of each bit that is a 1, then calculate the sum of the weight. Okay. You see this one, you times accordingly. For example, this one, this, okay, you get the answer. And for this one, now you can see that 2 to the power of 1, there is no multiplication here, right? Because it is 0. So anything times by 0 is 0. So that's why we proceed with the next one. This one. 1 times 2 to the power of 2. 1 times 2 to the power of 3 and so on. Then we get the number. Okay. Now, then we have 109. 109 is the base 10. Okay. Now the next we go to the binary to decimal conversion. Now we're going to convert from base 2 to base 10. Okay. The same example as the previous one. Okay. But this one is for the fraction numbers. Okay. So you multiply accordingly. 0.1 times to the power of minus 1. 0 times this one, nothing, everything times by 0 is 0. So we just proceed with this one and this one. Okay. 1 times to the power of 2 times negative 3. 1 times to the power of negative 4. This one. So you get this answer. So, and this is the base 10. Okay. Base 10, in normal life, we don't put it. Okay. But we can, you can put also, so nothing wrong. Okay. It's the base 10. Okay. Next, we go to the binary to decimal conversion. The same example. Okay. You just combine it accordingly. The same example as the previously. Previous is just separate. Now we combine the whole numbers and also the fraction numbers. Okay. You can try. Then we go to the next one. Decimal to binary conversion for the whole numbers. Okay. Now we're going to convert from base 10 to base 2. Okay, we do a repeated division by 2. Okay, divide the decimal number by 2, dividing each result quotient by 2 until the zero whole number quotient is obtained. We take the remainders generated from the division and form the binary numbers. The first remainder is set as least significant bit and the last remainder as most significant bit. Okay, we go to the example for easy understanding. Now, first we convert the decimal number of 12 to binary. I mean, this one is your 12 base 10. We want to have the binary number 2. Okay, here you can see for this one, first you divide 12 divided by 2, you have 6. Okay, then 6 divided by 2, you have 3, and 3 divided by 2, you have 1, and 1 divided by 2, you have 0. So here will be your most significant bit, and here will be your least significant bit. Okay, so you can see here, for example, 12. Okay, the initial divide by 2, you have 6, remainder 0, you put 0 here. 6 divided by 2, you have 3, remainder 0. 3 divided by 2, remainder 1. I mean, remainder 1, and you have 1 here. Okay, 3 divided by 2. So you take like this. Okay, so this is your most significant bit, and this is your least significant bit. So 12 to the power to the base 10 is actually equals to 1100. Okay, now for decimal to binary conversion for fractional numbers, okay, nombor perpuluhan, multiply, instead of dividing, we multiply the decimal number by 2, and repeating multiplying each resulting fractional part by 2 until the fractional product is 0. Okay, we take the carries generated by multiplication to form the binary numbers. The first carry product is set as MSB, and the last carry at least as least significant bit. Okay, no problem. We go to the example for easy understanding. The fractional number, instead of dividing, we are multiplying. Okay, when we want to convert from decimal 10, sorry, when we want to convert from decimal 10 to binary, okay, we multiply. So for example, for this number 0.3125, we times by 2, we're going to have 0.625. So our carry will be 0. Okay, and the first multiplication will be the most significant bit, and the last one will be the least significant bits. Okay, then the next one we put here 0.625 times 2, then you get 1.25. Then your carry will be 1. Okay, then the next one you go this for this one, and then 0.25. okay, you see 0.25, because you already take the one, 0.25 times by 2, you get 0.5. okay, so the carry will be 0, and then 0.5 times by 2, you finally have 1. We stop the multiplication or the conversion process when we have, for example, the fractional part are all 0. So taking this 1, we put it here. Okay, so from the most significant bit to the least significant bit, so we have 0.0101. Okay, now the next one, we go to the next, which is the octal numbers. Octal number is using 8-base system. Okay, for example, x base 8, we have 8-digit symbol, means that is from 0, 1 until 7. So example like 0, 1, 2, 3, 5, 6, 7, 10, 0, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 2, 0. But the digit will be never be greater than 7, because 7 is the highest digit, the highest symbol that we use. Okay, so we will continue this lecture to the part 2. Thank you.